Okay. All right, on problems 1 through 4, first of all, we could pick a point for each one of these, see what the slope was, and see if we could start matching it up. But we also should know a small shortcut in that if I have, for example, on C, see how C, my horizontal strips all have the same slope? Well, that gives us a hint. That means it's either all in terms of X or all in terms of Y. Do you remember which one? It's all in terms of Y when when the horizontal strips are the same. Another one I could look at would be like this one, B. My vertical strips they all have the same slope. So this has to be in terms of X. So I know that graph B could not go with numbers 3 and 4 or number 2, right? So graph B has to go with which one? This has to go with number 1. Okay, so I've used number 1. Which one has to go with number 2? Has to be C. Okay, so this is number 2. So then my only other ones I have to figure out would be this one and this one because they both are in terms of X's and Y's. Okay, here's the shortcut. This is a very common slope field to see, and it always will go with an X over a Y. Okay, it may be switched around, it might be Y over X, but anytime you see an X over a Y like this, it's always going to kind of look like a circle. All right, so D goes with number 3, which means A has to go with number 4. Now, if I totally forgot all of those little shortcuts, we could pick a point, like the point, 1, 0, plug it into my derivative, and see what the slope is and see if that little line matches up with the slope that I just found. That's the long way, but we could do it. Okay? So, any questions on that part? Number 2, the slope field from a certain differential equation is shown above, which the following could be a specific solution to that differential equation. So what do you think? A, B, C, D, or E? It is E. And if you're not for sure, you would need to kind of plug these in, try to adjust the window. Yeah. It just has to follow kind of the general shape. Yes, you can use your calculator on the test. Okay, on your test though, you guys hush. On your test, you will be using your calculator. All right, number 3. Or number 6. Provide the general solution to the differential equation. So when I'm solving the differential equations, what's the first thing I have to do? Okay, I have to separate my variables, then integrate. So separate and integrate. So on this one, I'm going to write dy equals y squared sine x dx. I just moved my dx over. And then what am I going to do next? Okay, I have to get my y's on the left-hand side, so I'm going to divide by y squared. So now I have dy over y squared equals sine x dx. So I separated my variables. Now I'm going to have to show that I'm integrating both sides. So when I integrate 1 over y squared, couldn't I write that as y to the negative 2? Okay, when I integrate y to the negative 2, I add 1 to the exponent, divide by my new exponent. So when I integrate this, I actually have negative 1 over y. So that's what I have on this side. Negative 1 over y equals, when I integrate sine x, what do I get? And is it positive or negative? It's negative cosine plus c. Okay, now when it says provide the general solution, that means that we want y equals something. So first of all, both of these sides are negative. Can I multiply by negative and get 1 over y equals positive cosine x plus c? I don't want 1 over y. I want y. So you could, well, doesn't it make sense if I flip this side over? I could flip this side over. I can do whatever I want to an equation as long as I do it to the same side. So if I flip my left-hand side, that's y. Flip my right-hand side, that's 1 over cosine plus c. Now, if you rewrote 1 over cosine x as secant x, then that's fine. Okay? And then that's my answer. All right, number 7. Find the general solution of the differential equation. So again, I'm going to separate, then integrate. So I have dy dx equals x over, sorry, so dy equals x over y dx. I multiplied both sides by dx. Multiply both sides by y, and I have y dy equals x dx. So I separated my variables. Now I'm going to show that I'm integrating both sides. So I have, when I integrate y squared over 2 equals x squared over 2 plus c. On this one, in our homework, normally, did we solve for y or did we solve for c? C, but I'm going to go ahead and multiply by 2 so I can get rid of those fractions. So I have y squared minus x squared equals c. I can leave it just like that. That's the general solution. I would not. I know it's not that hard. I can do that, but I wouldn't count it wrong. But for the test, I want you, if it's a y squared problem, I want you to solve for c. All right, number 8. Find the particular solution that satisfies the initial condition. So first of all, here's what I have. Square root of x plus the square root of y prime equals 0. What do I need to move? Okay, I'm going to move this x over. So, and when I do this, since I know I'm going to end up integrating, instead of using square root of x, I'm going to write those to the 1/2 power. So I have y to the 1/2 power times y prime equals negative x to the 1/2 power dx. So now I'm going to integrate. When I integrate y to the 1/2, I add 1 to the exponent. So y 1/2 plus 2/2 is 3/2 times 2/3. So I'm going to get 2/3 y to the 3/2 equals negative 2/3 x to the 3/2 plus c. Okay, so I'm going to go ahead and solve for c. So I have 2/3 y to the 3/2 plus 2/3 x to the 3/2 equals c. Okay. Can I go ahead and get rid of those 3's? So I have y, 2y to the 3/2 plus 2x to the 3/2. Okay, so I know what c is, but now I have this initial condition, 1, 4. So we're going to plug those numbers in. So I have 2 times 4 to the 3/2 Did I mess up somewhere? Yes. Yeah, I could. Yeah, so he said, could I go ahead and divide by 2 so to get rid of those? Yes. So I have 2 times x, so my x is 1. So 4, I have 2 times 4 to the 3 halves. That means the square root of 4 is 2. 2 cubed is 8. I don't know, let me see. Well, it depends. Let me show you. So this is going to be 2 equals c, so 16 plus 2 equals c. Okay, now I used what? This. Let's see. Where's my y equals? Um, I have my c is 18, right? Whoops. So I have to plug this in to my equation right here, right? I'm plugging it, either one. I can plug it into this one or this one. Are we good with that? So I'm going to plug it into this one right here. So when I plug it into that, here's what I have. I have 2y to the 3 halves plus 2x to the 3 halves equals 18. Okay? Now, that's fine. That is a correct answer. But he's saying, do you like my little square there? He's saying, well, what if I would have divided by 2? Well, if he would have divided by 2, he would have gotten 9 as his c. But look, if I divide everything here by 2, is that what I get? So it doesn't matter, all right? I could have divided everything by 2, plugged it in, and I would have gotten c is 9. But then these 2's wouldn't be there, so when I plug them in, I still get the same thing. Because if I divide everything by 2 here, I get this. Either answer is acceptable. Okay, Rick? Okay, so when he's saying he got 6 for C, and then when you plug it back into the original equation, whatever equation you used, and you simplify it, it's going to be some form of this. Does that make sense? Okay. All right. Number 9. Determine whether the function y equals cx to the third is a solution of the differential equation. So this is where we have to take this, okay, and see if we get a true equation. I have y equals cx to the third, and I need to know what y prime is. So let's find the derivative of y. So y prime equals, how do I find the derivative of cx to the third? Okay, bring down your exponent, 3 times cx squared. That's what y prime is. Okay, yes. When you are doing these, did you hear what Ryan said? He said 3 times c is just a constant c. When we're plugging it into to see if it's a differential equation, I go ahead and plug in what I actually got as my derivative. So here's what I would plug in. I would say x times y prime, and y prime is 3 times cx squared, minus 3 times y, and we know what y is, cx cubed, and that's supposed to be equal to 0. Okay? So this is what? 3 times cx to the third minus 3 times cx to the third. So determine whether the function is a solution. Yes, it's a solution because that gave me a true equation. So far, so good. All right, number 10. Number 10, consider the differential equation. On the x's provided, sketch a slope field. So I think you guys know how to do a slope field. I'm going to go ahead and just put in approximately what it should look like. I have zeros all there. It's kind of hard. So something like that. Okay, I didn't write down what each one of those points, what slope it gave me. And it should be right there. Now, part B, I'm going to look at the question B. It says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. So I can plot a slope for every point. Describe all points in the xy plane for which the slopes are negative. Okay, so if I were to keep on graphing this, they want to know which points would have a negative slope. Any ideas? Okay, everything below 2, and also everything that's on the y-axis, right? So when slopes are negative, so I'm going to write it on this. I have negative slopes where, and then let's do our y values first, where y is what? Less than 2. And where else? Where x is what? Not equal to 0. Where x is not equal to 0. Yep. Oops. Okay, you probably won't have a question like that on your test, but it's kind of nice to know what they're wanting. They're wanting you just to look at your points and tell me where would you have negative slopes. On part C, find the particular solution to the given differential equation with the initial condition 0, 0. So here was the initial problem. dy dx equals x to the 4th, y minus 2. So the first thing I have to do is separate my variables. So I have dy equals x to the 4th, y minus 2 dx. And then what do I need to do? Divide by y minus 2. So I have dy over y minus 2 equals x to the 4th dx. Say it again. For this one, well, if I have 1 over y minus 2, and I'm showing that I'm going to integrate both sides, okay, and u is y minus 2, what's the derivative of u? 1. Do I have 1? Yes. So when I integrate that, that's going to be what? Natural log of absolute value of u, and u is y minus 2, equals x to the 5th over 5 plus c. So what do you want to do now? No, no. What do you want to do now in the problem? What do you want to do now? We need to solve for c. Okay, our initial condition is what? 0, 0. Here's the deal. Look at this problem. Can I plug in my initial condition right now? First of all, if I just plugged a 0 in here, can I take the, oh, it is the natural log of absolute value. So it would be positive 2. So I could, okay? Um, what is, when I plug 0 in, okay? So natural log of 2 equals 0 over 5. So C equals natural log of 2. So I have the natural log of y minus 2 equals x to the 5th over 5 plus natural log of 2. I'm wondering if I want to do this or not. I'm trying to think ahead. So to solve for y, what would I do? E to both sides. E to the natural log of y minus 2 equals e to the x to the 5th over 5 plus natural log of 2. So I have y minus 2 equals, okay, e to the x over 5 over 5. Okay, but think of multiplied by what? Right? Why is he saying I'm multiplying by 2? Because e to the natural log of something is that something. So here's what I actually have. Y minus 2 equals e to the x over 5, or x to the 5th over 5 times 2. And now when I solve for y equals, I'm going to bring this 2 out in front. So 2x to the 5th over 5 plus 2. 2e. Thank you. All right, number 1. Let me see how long this is.